Okay. So guys, let me give you an example of what we're gonna do in chapter 8. Let's say someone make a claim that women spend more time online than men. I'll go to my sheet later. Well, this is a claim. We need to verify this claim, whether this is accurate claim or not. So we split the individuals in two groups. We have a group of women. Here's how we can do it. And a group of men. We try to survey a certain number of women and we ask them, how much time do you spend online? So we get a data set, we get a sample from them. And you guys, you have to do the same thing with the men. You get another sample. So I hope you understand now why it says 2 now, because we're comparing two population of women and population of men. We want to see if women spend more time on average than men. Okay, their average, because there are two averages here for the population, we're going to call their average is 1 and the man is 2. Usually the book does it this way. The one that he start talking about first, he could label it as 1 and then the second one will be 2. So I'm asking, do women spend more time online than men? That's the question. We need to address that. To address that, guys, you have to perform a hypothesis test. You get data about the women, you get data about the men, and then you perform a test. Now, what kind of test we need to perform? We need to check if mu1, which is the average time that women spend online, is bigger than mu2. So this is what the claim is. You already guys went through the greater than sign. You know, if it is a greater sign, that means this one should be an HA. And HO would be, can someone tell me what would the null hypothesis be here?
Less than or equal to.
You got it. And you test this claim, which I'm going to walk you through the 5 steps, and this is already the first step. So it could be this, or there's another scenario, guys. There are only 3 scenarios you have to select from. The nice thing about chapter 8, you don't put numbers here. You just 1 and 2, index 1, index 2, index 1, index 2, always. It could be that we wanted to test in another question that mu1 is less than mu2. Then the null hypothesis will be that. This is the third scenario, the second scenario. And the third one and the last one, guys, there are no other scenarios that you tell me I can think of. It's mu1 not equal to mu2. And then this one will be mu1 equals to mu2. So this is how to state, you state the hypothesis when you're comparing two population means. This is you're saying that mu1 is bigger than mu2. Here you're saying that mu1 is less than mu2. And over there you are saying that mu1 is different from mu2. So in any questions, guys, in section 8.1 and 8.2, your first step is one of the 3. You select either this or that one or this one. So this is going to be step number 1. I'm going to take you through the steps, guys. Step number 2 to find the test statistic. Step number 3 is the p-value. Step number 4, reject the null hypothesis or fail to reject the null hypothesis. And then step number 5, write your conclusion in words in the context of the claim. Nothing is going to be different from what we did with chapter 7. So let me just go back. So this is just an introduction of what you should expect in this chapter. And let's go back to this one. Chapter 8. First of all, I want to tell you what independent samples are, guys, because we'll be working with independent samples in section 8.1, 8.2, and 8.4. We say 2 samples are independent if the sample selected from one population is not related to the sample selected from the second population. Here is an example, guys. This is a sample 1, this is a sample 2. They have nothing in common. These are independent samples. But let me tell you what dependent samples are. Each member of one sample corresponds to a member of the other sample. Look how they relate. So in this illustration, I'm showing you an example of dependent samples. Let's take it one step further and just do some real examples. These are two samples right here. Weights of 65 college students before their freshman year begins. Weights of the same 65 college students after their freshman year begins. What do you guys think? Are they dependent or independent based on the definitions? Read carefully. Are they related, the two samples? If yes, that means they're not independent. What do you guys think?
Dependent?
They are dependent, exactly, because it is the same person that you're taking the weight of that person before their freshman year and after their freshman year. When it involves the same person before and after an action, they are dependent. Now let's see the next one. Scores for 38 adult males on a psychological screening test for attention deficit disorder, a score of 50 adult females in the same psychological screening test for attention deficit disorder. Your thoughts? Dependent or independent?
Independent?
Independent. They have nothing to do with each other. And I'll tell you a clue that will give you a hint that right away they're going to be independent. If it's not the same number of in the sample 1 and sample 2, then right away they are independent. It's impossible to be dependent, because dependent, it has to be the same number. One person in one sample relates to other sample. So this is an example of samples are dependent and independent. What we're going to do in section 8.1, 8.2, and 8.4 work with independent samples, and in section 8.3 we will work with dependent samples. So I'm going to take you right away to section 8.1, guys, and show you how we can perform the hypothesis. Here you go. This is section 8.1. I'll label it here. Okay, well, just a reminder that the null hypothesis must have one of those signs, less than or equal to, equal or greater than equal. The alternative hypothesis must contain a greater than, not equal to, or less than. These are the three scenarios, guys, that you have when you state the null in the alternative hypothesis. So in chapter 8, you just select one of the three. You don't have to think too much about writing the null in the alternative hypothesis. And we always begin with the assumption that HO is true until proven otherwise. It's just like the same in the justice examples. The defendant is not guilty until proven otherwise. To perform a two-sample, now it's not a z-test anymore, guys. It is a two-sample z-test. In order to perform a two-sample z-test, sigma 1 and sigma 2 must be known. The samples must be randomly selected. Always a good statistics when the samples are randomly selected. The samples must be independent, and the populations have to be bell-shaped, or the sample size must be more than 30. So you either have a population that is bell-shaped, but if it's not, if he gives you a sample size more than 30, we're good. How to perform the test? You state HO and HA. You calculate the standardized test statistic Z. You calculate the p-value. You make a decision about the p-value. If p-value is less than alpha, you reject HO. If p-value is more than alpha, you fail to reject HO. And let's do an exercise. A credit card watchdog group claims that there is a difference in the mini credit card debts of households in California and Illinois. So we have two populations, guys. The credit card holders in California and credit card holders in Illinois. They are independent because these people, some group live in California and the other one live in Illinois. So these are independent samples. the results of a random survey of 250 households from each. So the sample size is 250 from each. That meets the requirement of the test, are shown at the bottom. The two samples are independent. Well, they are independent right here. And they are random, guys, if you notice. So this is random, the samples are random. Assume, you see now some students asked me earlier, do we use Z when sigma is given? Look, it is given. It says sigma 1, not S1. So sigma 1 is 1045 and sigma 2 is 1350. Do the results support the group's claim? So are the condition of the test met? Yes, as I just explained to you. And now let me walk you through the 5 steps. Can you guys tell me which hypothesis we're gonna select? It says we need to test the claim that there is a difference in the mean credit card debit between the two states. So would it be the first one, the second, or the third? What do you guys think? 1 stands for California and 2 stands for Illinois. It is the first, exactly, Diva. Yes, we need to check if there is a difference, guys. Difference means not equal to. So right here. Okay. Let me write them down. HO mu1 equals mu2. HA mu1 is not equal to mu2. And this is the claim. Step 2, we're ready to use the calculator for this step. And let me show you the test. Turn the calculator on. Go to stat. I think, oh, sorry. Stat. Tests. And it is number 3. 2 sample Z test. Watch. It's asking me to enter sigma 1 and sigma 2. Let me show you sigma 1 and sigma 2, guys. Sigma 1 was 1045 and sigma 2 is 1350. So I'm gonna enter that. Now it's asking me to enter X1 bar, which already given to you guys, 4777, and X2 bar for 866, and the sample size are 250 each. If you have your calculator handy, please follow with me. And the second one is 4866. And N2 is 250. Enter. Now select the sign from the alternative hypothesis, which is not equal to, guys. And here you go, calculate. I got the information. Z is negative 0.82 and the p-value is 0.4098. It's huge. P-value is 0.4098, which is bigger than alpha. So decision will be fail to reject HO, fail to reject the null hypothesis. And if you fail to reject the null hypothesis, let me go to my yellow sheet from yesterday. Just to show you nothing has changed. It's exactly same output as in chapter 7. Our claim is in HA, and we fail to reject the null hypothesis. We say there is not enough evidence to support the claim. It's right here. So conclusion doesn't change, guys, between chapter 7 and 8. It's exactly the same thing. There is not enough evidence to support at what level of significance. Let me see what the level of significance in this exercise was. 0.05. Level of significance.
Can I see what you plugged in the calculator really quick?
Yes, just 1 second. To support the watchdog group claim. Okay, here's what I plugged into the calculator. So we went to stat, tests. You have to select 2 sample Z test. Okay, it's a summary. I don't have actual data. So I put sigma 1, then sigma 2, then I put x1 bar, then I put n1, then x2 bar, the mean from the second sample, which is Illinois, then n2 250, then I selected not equal to. I could have done a draw if you want to see the p-value, guys. It's a huge. See, that is the answer. Any questions? Okay. Okay, here's the conclusion sheet. You should have it also, send it to you. It is under resources by your instructor. These are the 4 scenarios, guys. 1, 2, 1, 2, depending where the claim is. Our claim is in HA. You either reject HO, and this is what you say, fail to reject HO. And this is what you say. If you want to take a screenshot of it, feel free right now. All right. Now, number 2. I'm keeping it handy so I can show it to you guys and show you that it does make sense. A travel agency claims that the average daily cost of meals and lodging for vacationing in Texas is less than that of Virginia. Okay, guys, before I continue, tell me which set we're going to use. They're claiming that vacationing in Texas costs less than Virginia. Which one would it be? The first set, second, or third? Third.
Third.
Yes. That's it, guys. Once you figure this out, it's going to be, they call it a piece of cake. mu1 is less than mu2. Claim mu1 is greater than or equal to mu2. He put Texas first. As you notice, it's labeled 1, and Virginia is 2. He gives me sigma 1 and sigma 2, so this is an indicator. It's a 2 sample Z test, guys. And that both populations are normally distributed, they are independent, they're randomly selected so that the conditions of the test are met. Is there enough evidence to support the claim? Okay, let's study the claim. Go to stat, tests, 2 sample Z test. Okay, sigma 1. Sigma 1 is 19 and sigma 2 is 24. X1 bar, $234. N1 is 25. X2 bar is 240. They seem to be about the same. And 20. And we need to check that mu1 is less than mu2. That's my alternative hypothesis. And here you go, guys. Calculate. So I'm done with the calculator. Z is negative 0.91 and p-value is 0.1808. Uh, 0.1808. The p-value, guys, is the area to the left of Z. But you don't need to do it with normal CDF. It's just like what I did when I introduced it. But since this is a left tail test, it's a less than, the p-value is the area to the left of negative 0.91. If you try to use normal CDF and find the area to the left of this, you're going to get that. Okay, all I care about that the p-value is more than alpha here, which is 0.01. So we fail to reject HO. Okay. If you fail to reject HO, guys, one more time. The claim is in HA. I fail to reject HO. What's my conclusion? There is not enough evidence to support the claim. He's asking us, can you support the claim? Well, we say no. There is not enough evidence at the 0.01 level of significance to support the claim. And what is the claim? You need to know what the claim. Sometimes, you know, when you do your homework online, it asks you to select the claim. To support the claim that the average daily cost of meals and lodging for vacationing in Texas is less than that of Virginia. You notice from the sample, there were not much difference, so we couldn't say that one is less than the other. And I am done with section 8.1, guys. So a summary: perform a two-sample z-test for the difference between two means in mu1 and mu2 with independent samples when sigma 1 and sigma 2 is known. Okay, I just wanna, if you go on YouTube, guys, or some other websites online, sometimes instead of listing the hypotheses like this, watch, I'm gonna show you another way to list them, and they are the same. They list them this way. And tell me if you think it is exactly the same thing. This way of listing the hypothesis is exactly the same. What this means, guys, if mu1 is less than mu2, if you subtract mu1 from both sides, you get mu1 minus mu2 less than 0. And here, if you subtract mu2 from both sides, you get mu1 minus mu2 greater than or equal to 0. So if you see something like that come across this, it's exactly the same as that. Okay, section 8.2.
I have a question.
Mm-hmm.
The first exercise that we had was a dependent and the other one was independent. There's no difference between both when we calculate them?
Oh yeah, there is a big difference. We're dealing only with independent sets. Section 8.3 deal with dependent, which is going to be treated very differently.
Does the number have to be the same, which is n?
Oh, n has to be the same for dependent samples, definitely. But not in this case. Look, this one, for example, 8 and 18. Once you see that the numbers are not the same, they are independent. And we're only working with independent samples. How to test the hypothesis for two samples that are dependent will come up next, okay?
Okay, thank you.
Yeah. Okay, this is section 8.2, guys. This is the popular one. 8.2. What does it say? Testing the difference between two means, independent samples again, but sigma 1 and sigma 2 are unknown, which should be the case here. We don't know the population standard deviations. Okay. Condition of the test. Sigma 1, sigma 2 are unknown. So instead, he's going to give you S1, S2 given. Samples are random. Samples are independent. The population are normally distributed, or the sample size must be bigger than 30. How do you test the hypothesis? Same steps, guys, just like we did in section 8.1. How do you state the hypothesis? Same thing as before. Mu1 equals mu2, and then you can write with me, guys. Mu1 is different from mu2. That's one scenario. Or mu1 is less than or equal to mu2. Mu1 is greater than mu2. Second scenario. Mu1 is greater than or equal to mu2, mu1 is less than mu2. These are the same scenarios as in section 8.1. Nothing is going to change. The only thing, the name of that test is going to change. Instead of two sample z-test, guys, you will be working with two sample t-test. And let me begin. I'll come to this in a second. That's very, very important when you use calculator. The results of a state mathematics test for random samples of students taught by two different teachers at the same school are shown below. Can you conclude that there is a difference in the mean mathematics test scores of the students for the students of the two teachers? So he wants to check if there is a difference. Use alpha equals 10%, assume that population are normally distributed and the population variances are not equal. So which one is it gonna be, guys? First, second, or third? We wanted to check that if there is a difference in the mean math test scores. With a student, first one, yes. I agree. Step one. mu1 equals mu2. It's very simple, guys. Once you figure out what the null alternative hypotheses are. Okay, that shouldn't be okay. Step two, okay, instead, because he gives me S1 and S2, please pay attention, guys. This is critical. It's tempting to go to two sample z-test always, but you can't. Look, he gives you S1 and S2, unlike in section 8.1, he put sigma 1 and sigma 2. Once you see S1, S2, this is gonna lead you to two sample t-test. Okay, let me go and process this. Ready to do this. Stat. Two sample t-test is number 4. All right, X1 bar. He wants X1 bar, which is 473. S1, you see he's asking for S1 now, not sigma 1, 39.7. N1, 8. Now X2 bar, guys, you can see it's 459. S2, 24.5. N2, which is 18. Okay. mu1 is different from mu2. That's my alternative. There's one more before we hit, and that's, please pay attention. It's asking you, pooled, yes or no. Here's how you determine whether it is yes or no. If he says population variances are not equal, it's a no. If he says population variances are assumed to be equal, it's a yes. So we select pooled. Yes, if the population variances are equal, and select pooled no if the population variances are not equal. You always have to make that selection. So because he says here, look guys, he says assume population variances are not equal, I'm gonna select no. Here's the no, and now we're ready, calculate. So this is T, p-value, degrees of freedom, everything that you need here. Okay, hope that you got the same results if you're following along. So T is 0.922. And p-value, that's all I need of the calculator, and I'm done with the calculator. 0.3792. And let me just put here, select pooled, no, because population variances are not equal.
Can you move the paper up just a little bit?
Yes, sure. Population variances are not equal. Okay, guys, and the conclusion and decision is exactly as we've been doing in chapter 7. This is bigger than alpha. You fail to reject HO. So same conclusion in all 3 problems already. And the claim happened to be in HA, it's same scenario as the previous 2 exercises, guys. There is not enough. I just put those problems. I didn't intend for all to be failed to reject HO. There's not enough evidence at the 0.10 level of significance to support. You have to use the word support when the claim is in HA. Either you say support or cannot support. Here, cannot support. to support the claim. And what is the claim? That there is a difference in the mean mathematics test scores for the students of the two teachers. So we're saying we cannot support that there is a difference, so probably there is not a difference between the two. Any questions, guys? Oh, the claim here in HA, because he says test that there is a difference. Difference, guys, means not equal to. So difference. If I wanted the claim to be in HO, I say test the claim that they are the same. Then the claim would have been in the null hypothesis. Okay. Next question. Okay, here you have to add some data. I think I forgot to include that, but I'll do it right here. A manufacturer claims that the calling range in feet of its 2.4 gigahertz cordless telephone is greater than that of its leading competitor. Okay, let me just create a list. This is the competitor here. And this is the manufacturer. You perform a study using 14 randomly selected phones from the manufacturer. So N1 from the manufacturer is going to be what? 14, guys. And 16 randomly selected similar phones from the competitor. So N2 is 16. The results from the manufacturer have a sample mean of 230 feet. So this is X1 bar. And a standard deviation of 26. So S1, he didn't say population standard deviation, so it must be S, not sigma. And he must give me information about the competitor now. The results from the competitor have a sample mean of 216. We call it 2. We don't call it X1 because X1 already reserved for this. 216 feet with a standard deviation of 32. At alpha equals 5%, can you support the manufacturer claim? Assume that the population are normally distributed and the population variances are equal. Now this, guys, means when it comes to pooled, you're gonna choose yes. All right, it is a two-sample t-test. And again, if you ask me, how do I know? He gives me S1 and S2 instead of sigma 1, sigma 2. It is a two-sample t-test. Okay, we want to check that the manufacturer claim that their calling range is greater than the leading competitor. So you guys should agree with me that HA should be this mu1 greater than mu2. And 1 is reserved for the manufacturer and 2 for the competitor. And this one will be mu1 is less than or equal to mu2. All right, let's run the test. Stat tests, two-sample t-test, stats. Okay, X1 bar. Let's do it together. So we have 230. S1, we have 26, then we have 14, X2 bar 216, S2 is 32. So not always he'll give you the data in a table, just like I did before, but to make it easier for you to get it, I just summarize them and put them in the table. You don't have to. N2 is 16. And then we need to test that mu1 is bigger than mu2 right here. And then here, pooled. He says population variances are equal. Assume they are equal, so you must select yes. And when you select yes, you must press enter, guys, to make the selection effective. Now it is effective. And calculate. And here you go. T is 1.303 with 3 decimal places, and p-value is 0.1017. And here is the p-value, 0.1017. And you guys can tell me now, we'll compare it with alpha. Alpha is 0.05. So the decision, if the p-value is more than alpha, you fail to reject HO. Oh, wow, the fourth one, fail to reject HO. So again, there is not. Every time you have a fail, you have to do there is not. These together. Enough evidence to at the 5% level of significance. If you were doing this as a homework online, when you do step 5, the system is gonna give you a drop-down menu, and you have to choose. Here there is and there is not. You have to choose there is not because it's failed. Then you're gonna get another drop menu that has support or reject. Every time the claim, guys, is in HA, you cannot use the word reject. So you have to use the word support. So there is not enough evidence at the 5% level of significance, and then you select support. Support the claim, the manufacturer claim. So probably their claim about their phones is not correct, guys. We could not support it. All right. So this is section 8.2.
These are all independent?
Yeah, definitely, because it's a competitor and a manufacturer, two different places. Look, dependent, guys, it has to be the same person doing something before and doing something else after. It has to be the same person. Here we're saying we took 14 phones from this manufacturer and we took 16 phones from the competitor. They have nothing to do with each other. And what makes them right away independent, not the same sample size. Even if they were the same sample size, they are still independent. They won't be dependent. Dependent, it has to be same person. Like you took the blood pressure of a student before he took the quiz and while taking the quiz. That is dependent when the action pertained twice to the same person. So these are all independent samples. Perform a 2-sample t-test for the difference between two means, mu1 and mu2, with independent samples. When sigma 1 and sigma 2 are unknown, we use the 2-sample t-test, as I said. All right, guys, that concludes section 8.2. Now I'm gonna go to 8.4 because it deals with independent samples, and then I'll come back to the t-test where we do dependent samples. So I'm just gonna take you right away. Section 8.4. All right, watch. This is about the proportions, not the means anymore. So the first two sections deal with the means, difference between two means. Now this is gonna be a difference between two proportions. And guys, stating the null and alternative hypothesis is not gonna be any difference. You could have an equal or not equal here. Or you could have P1 less than or equal to P2. P1 is bigger than P2. Or you could have P1 is greater than or equal to P2 or P1 less than P2 when testing the proportion. It's one of those three. Okay, what are the conditions of the test? The samples must be randomly selected. The samples must be independent. And the samples must be large enough so that we have N1 P1 greater than 5, N1 Q1 greater than 5, N2 P2 greater than 5, N2 Q2 greater than 5, just like in testing the proportion. I'll show you how to demonstrate that in a second. 2 samples z-test for the difference between proportions. So these are the conditions of the test, and these are the steps. And you guys notice they're not any different from before. Actually, I cut and paste from section 8.1 and I put them here. You have to state the same steps. Let me take to an example right away and show you how to work with the proportions, comparing two proportions. In a study of 150 randomly selected occupants in passenger cars. So we have two sets here. Passenger cars and then randomly pickup trucks. You talk about pickup trucks. Okay, let's see. In a study of 150 randomly selected occupants in passenger cars. So this is the sample size for passenger. Since guys, I'm gonna have two sample sizes, so this one must be called N1. And then 200 randomly selected occupants in pickup trucks. This is gonna be N2. 86% of occupants of passenger cars, so let me put this, the 86%. And 74% of occupants in pickup trucks wear seat belts. At alpha equals 10%, or 0.10, can you reject the claim that the proportion of occupants who wear seat belts is the same for passenger cars and pickup trucks? So guys, here's the claim. Can you reject the claim that the proportion of occupants who wear seat belts is the same for pickup trucks and passenger cars? So can you guys tell me which one is it gonna be, first, second, or third?
First.
First, yes. And guys, the claim now is not in the alternative. He says, can you reject the claim that the proportion of passenger cars and pickup trucks is the same? The claim is right here. And the reason why guys didn't ask you, can you support the claim? When the claim falls in the null hypothesis, no one speaks the language of support for it. So that's why it's, can you reject the claim? You can never put the word support when the claim is in the null hypothesis. You either gonna conclude you have enough evidence to reject the claim, you don't have enough evidence to reject the claim, but you don't use the word support. Just to show you guys here, we haven't put the last two scenarios to use. Well, this is it. Claim is in HO now. This is now the case. If you reject HO, you say, I have enough evidence to reject the claim. If you fail to reject HO, you say, I don't have enough evidence to reject the claim. You see the word reject in scenario 3 and 4, and the word support in scenario 1 and 2. All right. He didn't ask me to check the requirements of the test, so I don't need to check the requirements of the test. You can proceed right away to the test. Because there are two proportion, guys, there is a test built in the calculator. It's called two proportion z-test. And let me take you to it and see how we're gonna do this one. On stat. Look, guys, it's number 6. Okay. Now you need to help me a little bit because we need now the calculator. Just like in the proportion test that we did yesterday, the calculator requires two values, the sample size and the number of successes X. Here, he gave me the sample size, which is 150, but he didn't even give me X directly. He gave me the sample proportion, 86%. So how am I gonna find X, guys? Still remember what we said yesterday?
Do 86% of 150.
Exactly. 86% times 150. And same thing, guys, here. And if it doesn't turn out to be a whole number, guys, you better round it and make it a whole number. So 0.86, oops, let me just clear here. Okay, 0.86. I think it's going to be a whole number. So I got 129. And that's easy, 152. Okay, I think we're ready to go now. Stat, tests. Number 6, guys.
You did 76% times 200.
Yes.
I can't.
It's 70.
Yeah, 152. It's right here. Yeah.
Is it 74%?
Is it 74 or 76? Oh, 74. I made a mistake. You're right. So it's 148. Good. Thanks for noticing. Okay, so X1. We need the X1, 129. N1, 150. It's very straightforward, guys, once you figure out what to do. X2, 148. Don't ever put X2 to be 74%. It has to be 74% of the total, make sure. N2 is 200. We are checking that P1 is not equal to P2 as an alternative hypothesis. And let me do a draw for you here. Oh, no p-values. It must be very small. So Z is 2.73 and p-value is 0.0062. P-value is 0.0062, which is less than alpha. It's a very small number, guys. So reject HO. Yeah, that's good. First time we reject the null hypothesis. So what do we say? Here you go. Watch. Back to my yellow sheet. The claim is in HO and I reject HO. Well, your claim is built in HO and you say HO is bad. That means you reject your claim. So you say there is enough evidence to reject the claim. And definitely you want to mention the significance level right there. So there is enough evidence at the 0.10 level of significance to reject the claim. That the proportion of occupants who wear seat belts is the same for passenger cars and pickup trucks. So they're not the same. Be honest with you, people who drive bigger cars usually tend not to wear the seat belt as much as the ones who wear smaller cars. So actually the proportion wasn't going to be the same. And we just proved that we have enough evidence to reject the claim that the proportions are the same. Because people who drive bigger cars feel a little bit safer. So then they think that there is no need to wear the seat belt when you're driving a big vehicle. So that is the first example. We're going to do another one. Again, section 8.4, guys. A medical research team conducted a study to test the effect of a cholesterol-reducing medication. At the end of the study, the researchers found that of the 4,700 randomly selected subjects who took the medication, 301 died of heart disease. Of the 4,300 randomly selected subjects who took the placebo, it's a sugar pill, guys, 357 died of heart disease. At alpha equals 1%, can you conclude that the death rate means a proportion, due to heart disease is lower for those who took the medication than for those who took the placebo? Okay, guys, if I put the three scenarios here, which one would you choose? He wants us to check if the death rate for the ones who took the medication is less than the death rate for the one who took nothing. So which one would it be? First, second, or third? Third one, because P1 is the medication and P2 is the placebo. Exactly. So let me just do it right here, guys. Give you the table. Medication. It will help you if you do that when you enter stuff into the calculator. Okay, how many did we took? N1 was 4,700 and X1 was 301. For N2, it was 4,300, guys, and X2, 359, and alpha is 0.01. That's all I need. And I need to check that the rate of death from medication is less than the rate of death from placebo. So I agree with you what you said. P1 is less than P2. Claim. Don't forget the column here, guys. That's very important. You just state it like that. And it's a 2 proportion z-test. Why 2? Because it's 2 samples. You can see sample 1, sample 2. All right.
It said like at most, then it would be HO is the claim.
Yes. If it says at most or at least, yes, HO will be the claim. Exactly.
Okay.
Just follow the question, guys. Whatever the question he asks you, this is the claim. Can you conclude that this and that is the claim? All right. So you see here, can you conclude? That's the claim. That's the question. This is your claim. Okay. 2 proportion z-test. Stat. Calc. Okay. We need to do some data entry here. X1 is 301. N1 is 4700. X2. See, when it comes to medication, you have to have a large sample, and that's why this example has a large sample. You can't just have 100 patients. That wouldn't be enough. 4300. And we need to check that P1 is that. Don't forget to change this one. It's very important. You select it and press enter and then hit calculate. Z is negative 3.53 and look at the p-value. I'm gonna copy it as is and explain it to you. It says 2.04 E minus 4. Don't forget the E there. So Z is negative 3.53. And let me write the p-value and then we'll interpret it. It's 2.04 E minus 4. You cannot type in this value in the homework or when you take the quiz. You have to change it to a decimal. That means you have to move the decimal point 4 digits to the left. If you move it 4 digits to the left, guys, it's going to be 0.00204. So if you're doing your homework online, it says round to 3 decimal places, it will be 0.000. 4 decimal places, 0.0002, which is definitely less than alpha. Once you see the E, right away, guys, less than alpha. So reject HO. Okay, back to my yellow sheet. That should become your favorite sheet until you're done with this course. The claim is in HA and you reject HO. Well, you reject the first one and the claim happened to be in the second, then you support the claim. There is enough evidence to support the claim. I'll write it down. At the 0.01, you notice alpha is small when it comes to testing stuff for medical field. At the 0.01 level of significance, I think the FDA requires all study to be done at alpha equals 0.01, not anything higher than this. So there is enough evidence at the 0.01 level of significance to conclude, to support the claim, to support, or you can say conclude, to support the claim that the death rate due to heart disease is lower for those who took the medication than the ones who took placebo. You just copy it and paste it. That concludes section 8.4, guys. As you can see, it is a continuation of what we have been doing. Now, I'm not gonna go over those exercises, but these are already worked out for you. So there is an example from section 8.1. If you can see that, it's already done for you as additional exercises. There's another one, a third one from section 8.3, which we're gonna go over now. A few exercises from section 8.2, but Once I finish 8.3, guys, we're going to do some of the review exercises today and tomorrow to help you prepare for the test. So I put 5 questions here without answers, which we will go over together. But the ones with answers, I'm not going to go over them because you already have the detailed answers. Not only the detailed answers, guys, the screenshots of the calculator. So I hope that you'll find them useful. It took me quite a bit of time to just put those together. So please make use of them. What I'm going to do now, I'm going to go back to section 8.3 and show you how 8.3 works. Remember, 8.3 is very different. It is about dependent samples. So we're going to go to it right now. I left it to the end, not because it's not important. Actually, it is more important than all other sections in 8, but because the way you work it out, it's very different. So section 8.3 here, if you guys want to take a note, that's 8.3. All right. The conditions of the test. The samples must be randomly selected and they must be what? Dependent. Dependent, they call them paired, means each member of one set has a relationship with another member in the other set. Population must be bell-shaped or the sample sizes must be at least 30. In this case, if we have those 3 conditions, we are ready to deal with dependent samples. Before I fill this out, guys, I'm just going to go to the example and start talking about it, and then I'll come back and fill out the details here. So please pay attention to this. It's very different from the previous 3 sections, and you will see why in a second. Now, to perform a t-test, the samples are random. The samples are dependent, not independent anymore, or paired. They call it matched pair, or the population are normally distributed, or the sample size is more than 30. The steps, guys, nothing different from before. HO, HA, calculate the standardized test statistic, calculate the p-value, make a decision to reject or fail to reject HO, and then interpret the decision. Let me show you how it works. With this example, we'll do this example, and then you'll have a good feel of how this section works, guys. A shoe manufacturer claims that the athletes can increase their vertical jump heights using the manufacturer training shoes. So athletes, if they try the manufacturer training shoes, they can have a higher vertical jump. The vertical jump heights of 8 randomly selected athletes are measured. After the athlete have used the training shoes for 8 months, their vertical jump heights are measured again. So what they did, they brought in 8 athletes. They checked their vertical jump before they wear the manufacturer shoes, and then they checked again after they tried the manufacturer shoes and see if the shoes will increase the vertical jump. Assuming the vertical jump heights are normally distributed, is there enough evidence to support the manufacturer claim that if an athlete uses their shoes, they're going to have a higher vertical jump? Would you guys agree with me that the 2 sets are dependent here from what you see? Why they are dependent? Because look, this is athlete 1. His vertical jump was 24 before he put the manufacturer's shoes on. And then after he put the manufacturer's shoes on and did some training, it went up to 26. So it is the same person. Old and new, before and after, it's the same person. Then these samples are dependent. Okay. Can you guys tell me if it did make a difference for this person? What's the difference between 24 and 26? 2. So it went up a 2. So what's 24 minus 26 here? Is -2. What about this guy? Did it help? 22 and went up to 25. Well, it looks like it helped here. What about this guy?
No.
25, 21, the difference is 0. So I'm doing the difference for a good purpose, guys. You will know for a second why. What about 28 to 29? 28 minus 29, it gives you a negative. So it seems to me when you get a negative answer, that means it worked. If you get a positive answer, maybe it didn't work. And if you get a 0, means neutral, neither worked or didn't work. What about this guy? He was doing 35 before and he did 33 now. So what's the difference, guys? Do you agree if 35 minus 33 is 2? Do you think it worked for athlete number 5? Yes or no? Yes? No? What do you guys think? I hope that you are listening. No, it didn't work. Yes. So if you get a positive answer when you subtract, it didn't work. 32 minus 34, it's a negative 2. It did work for this guy. 30 to 35. Oh, that worked quite well for this person here, negative 5. And this guy went from 27 to 30. That's a negative 3. So would you guys agree with me if I tell you if the answer was negative, it means it worked? And if the answer was positive, it means it didn't work. And if it was 0, no change. This is how you check. But based on what I just did, what do you guys feel? Do you feel that wearing the shoes do work in general on average? Yes or no? Yes. You could say yes, but you still need to perform a hypothesis test. And now I'm going to show you guys how to perform the test. When you test 2 samples that are dependent, you do the difference. And that's what we just did right here. When the samples are dependent, you don't write mu1 and mu2 just like we did in section 8.1 and 8.2. You do the difference and you decide to, and you test the difference against the number 0, whether the difference is negative, whether the difference is positive, whether the difference equal to 0 or not equal to 0. So we're testing against 0 in section 8.3. Now, guys, you notice, yes? Any questions? All right, so we test the difference. So the first step, guys, when you have dependent samples, you do the difference D. And you agreed with me, if this turned out to be negative, it works. If it turns out positive, it doesn't work. So because we want to test the manufacturer claim that it does work, so you need to test that the difference is negative. Need to test that the difference is negative. And I'm going to show you how to write this. So you write that HOHA. You put this symbol. This means mean of the difference, the average of the difference. You want to check if it is less than 0. Because we agreed if we get a difference less than 0, that means it's working. Greater or equal to 0, it's not working. This is the claim, guys. So if I go back to my sheet right here, and I want to fill in the blanks, when you do paired samples, dependent samples, you have 3 scenarios. Mu of D, not equal to 0, equal to 0, that's the first one. The second one, greater than or equal to 0, mean of the difference less than 0, that's the second one. And then the third one, mu of D is less than or equal to 0, mu of D greater than 0. We decided that we were going to use this one for our exercise. So you test the difference. Now, guys, you can forget about this sample and that sample. We no longer need them. We only need the difference. So actually, I showed you how to convert this one from 2 dependent samples to only 1 sample, which is the difference. So what I'd like you to do, guys, in order to solve this problem, input the data of the difference in L1 right now. So let's do it. Stat, edit. Okay, I'm gonna clear, let me just clear L1. Clear, hit clear and enter. And then I'm gonna input the data. So I got -2, -3. I'll show you the list once I do it. 0, -1, 2, -2, then -5, then -3. Probably we're gonna support the claim because most of the numbers are negative. Let me just clear L2 so it doesn't bother you while looking at the screen. So this is L1. Okay, so this is the next step. Input in L1. And we decided this is the null and the alternative hypothesis, and we need to test that the difference is less than 0, because if it is less than 0, it will work in the manufacturer favor. Okay, what kind of test do we perform? It's not a 2-sample test anymore, guys. We perform a t-test on the difference. So we're back to chapter 7, only a t-test on the difference right here. And let me show you what you do. So you go to stat, tests. That's why I told you this section is different. I left it to the end. T-test with data. I have my data in L1. When you do section 8.3, guys, you can take a note. This is always 0. That doesn't change. We're testing against 0. Just to show you again. Watch, guys. 0, 0, 0. It's 0 everywhere. So it's against 0. My data is in L1. I put it in L1. My frequency is 1. And what is the alternative sign? Here you go, next to you guys. It is less than. So just choose less than. Okay. So T is -2.33. P value is 0.0262. And what is my conclusion? What's alpha here? At 10%. This is less than alpha. You reject HO. And if you reject the null hypothesis, guys, and the claim happened to aid in HA, you support the claim. There is enough evidence at the 0.10 level of significance to support the manufacturer claim. And we noticed it was working for most of them except for 2. So in general, it was gonna work to support the manufacturer claim. That the vertical jump heights will improve as a result of wearing their training shoes. Now, guys, I have to bring one thing to your attention. When you do this kind of work online, the first question is going to ask you to find the difference. You will find the difference. Before you do a hypothesis test, my math lab might ask you to find the mean of the difference and the standard deviation of the difference in the data set. Do you guys still remember how to find the mean and the standard deviation if you have a data set? That's something we did in chapter 2. I don't want you to do anything by hand. I mean, you could add them up and divide by 8 and you get the mean, but the standard deviation is a lot of work, to do it by hand. Do you guys still remember how we go about finding the mean and the standard deviation? What do I do? Stat, let me show you. Calc, one variable statistic, and then enter. Here you go. X bar is the mean, which is -1.75. Don't be surprised it's negative because all the data are negative. And S is the standard deviation, which is 2.0. 12. In the book, they are labeled like that. D bar is the sample mean of the difference. So you might be asked to find D bar before you just run the test. And SD is the standard deviation, sample standard deviation of the difference.
So we just leave that screen and just switch it to one variable.
Yeah, one variable statistic. If before even you run, no, you're gonna do it before you run a hypothesis test. So just do that. And the reason why he asked, because he assumes that students are doing the work by hand and finding, you know, the test statistic T by hand, the p-value by hand, but you are using the calculator, but there is no escape. Sometimes a good question I put here, their hypothesis testing, he will ask, you know, to find S and D bar. Just find him and then go back and run a t-test. And once you run a t-test, you're just gonna get the results here. So this is for dependent samples. Let me see how much time we have. Okay, I have a few more minutes. I just want to go over one more problem, but tomorrow, guys, we'll do a good review of chapter 7 and 8. So let me just, let's run quickly through this one, guys, which is number 5. And the handout. That's the last sheet of the chapter 8 guided notebook. Physical education director claims by taking a special vitamin, a weightlifter can increase his strength. 8 athletes are selected and given a test of strength. Using the standard bench press, after 2 weeks of regular training supplemented with the vitamin, they are tested again. So this is before they take the vitamin and after they take the vitamin. Test the effectiveness of the vitamin regimen at alpha equals 0.05. Each value in this data represents a maximum number of pounds the athletes can bench press. Assume the variable is approximately normally distributed. So the first thing, guys, you have to do the difference for me. Do you agree that these are dependent because it's the same athlete before and after they take the vitamin? This is before they take the vitamin and this is after they take the vitamin. Let's see what's the difference. 210 minus 219, it will be what? -9. 230 minus 236, it's -6. 182 minus 179, this is a 3. 205 minus 204, 1. 262 minus 270 is -8. 253 minus 250, it's a 3. 219 minus 222, it's -3. And 216 minus 216 is 0. Okay. In your opinion, guys, if the difference is negative, does it mean it's working or not working? Can someone answer this question? You need to know because you need to state the null and the alternative hypothesis.
It's working.
It is working because you get a number which is bigger after. So when you subtract, you get, so that means we need to test the difference to be negative, just like in the previous exercise. So look, guys, HO, I'm not saying this is always the case, but it happened to be the case in this. We need to test this. So you're gonna be in the spot of the one who's making the claim and ask yourself, what do I test in order for this to check if it is working or not? You want to check that the mean of the difference is less than 0. It looks like it is less than 0 in 4 places, more than 0 in other places. So now I cannot tell you guys if we're going to support the claim because there's a fluctuation. Positive, negative, worked for others, didn't work for the rest. I'm not sure, so we're going to check. So we're going to put this in L1. Input in L1. Let's do it quickly. Then I'll let you go, guys. Just bear with me. So I'm going to put him in L1, -9, -6, 3. Make sure to use the negative sign when you put into the calculator the data. -8, 3, -3, and then 0. And what I mean by negative sign, this is the negative sign right here. Okay, I put my data in L1, guys. I'm gonna run the test, stat, tests, t-test, data. It's always data in section 8.3. You choose data. It's against 0. I put my data in L1. It's gonna be exactly like the previous exercise. And calculate. There you go. So t is negative 1.388. And p-value, guys, is 0.1038. Oh, that's a huge, that's big, which is more than alpha. So what's the decision here?
Fail to reject.
Fail to reject HO. I hope that you guys by now you have a good feel of when to reject HO and fail to reject HO. Okay, if I fail to reject HO, and last thing, guys, for today, the claim is in HA, and I fail to reject HO, I say I cannot support the claim. There is not enough evidence to support the claim. So probably the vitamin doesn't work, guys. There is not, to increase the bench press strength, there is not enough evidence at the, what was it, alpha, 5% level of significance to support the claim. All right, guys, so that's it. I still have a few more questions I didn't answer in the review sheet. I will do them tomorrow, question 1, 2, 3, 4. But then you notice there are some questions that I worked out with calculator screenshots. So you already have about 10 or 15 questions that are already done. You can use them to go back and review for this chapter. And if he asks you to find the mean and the standard deviation of the difference, guys, for this one, again, you just go to stat, calc, one variable statistic, and just hit enter. This is the mean of the difference, which is negative, and this is S because it's a sample. That would be the standard deviation right here. All right, that's it.
Quick question.